Let me do that. That. I think. Okay, so let's just pull this over here. So these were the problems you guys had to do. So were there any of those that you wanted to ask about anything I did, or you would like me to do something different like you were trying and you got stuck? I will gladly do that. This is your chance to go ahead and try to get help and figure things out, because once we're done with these, I have this sheet that has about 46 of them on it. We're not doing all of them. I'm just going to say, let's do number blah, blah, blah. Let's just was easier than making a new thing. Okay. Yeah, Ryan. Number 2. When you say number 2, the blue number 2 or the red 2? The blue 2. Okay. Let's look at number 2. I think did I put these in? Okay, so here it is. This is the blue 2. Okay. And so let's go ahead and talk about it. So you want me to explain what I did, or you try to do something different?
Yeah, I don't understand your first step. Like, because
what my first step is? Okay, my first step here is a GCF on the left-hand side. Okay, so what I did was I factored out, I took a sine theta out of this and a sine theta out of that. So think of this like x cubed x cubed plus xy squared. Greatest common factor there is what? X. So you pull out an x, right? So that's kind of what I did up there.
I was just confused because I didn't know that, like, the plus and like the multiply, I thought it would be like sine squared theta multiplied by this. That's what I did.
But it's
instead of plus. It's
a plus there. It's no different than this. If you pull out, it's like if you had this. If I had 2x plus 8 and you pull out the greatest common factor there, what is it? Yeah, it's 2 times x plus 4. That stays addition. Just like that would stay addition. No different. It looks different, but it is no different than this. Okay? Anybody else have one on that? Anything else that we're asking about that particular problem? Yeah. Different problem? Okay. Which one did you want to look at, Caitlin? When you say 3, blue or red? Blue, red. Okay, blue to number 3. I'm not. Is this number 3? This is 3. Okay. So this one, let me do this real fast. Let me just clone this page. Okay. Here. This. So what did you start doing something completely different on it?
So I changed the left side to sine x times sine 2 third.
So you worked on the left-hand side.
I worked on both sides.
You worked on both sides. Okay. So let me go ahead. Let's just get rid of this. So tell me what you did first again.
So I changed the left side to sine x times sine to the 4th x times cosine squared x.
Okay.
And then I wanted to make the other side equal to that.
Okay. So then what did you do on the other side then? You can do that. You can say, I'm going to change the left-hand side like this, and now I'm going to try to make the right look like this. That's okay, as long as you're working with one side at a time. Can you tell what you did?
I think I got the answer.
So it looks. sine squared x. And where this sine x, I'm not sure what's going on here. Here, it looks like you just took a parenthesis and put it here and here. You moved it. And here's the same thing. And then all of a sudden, this sine x became sine squared x. And it's like you took this sine x times this sine x and made it sine squared x. But in order of operations, can I do this if this is held on a subtraction? I can't do that, okay? I understand what you're thinking, but you can't do that. Anybody else want to say anything about this one, or? Yeah.
So that's how you did it.
Uh-huh.
Your GCF.
So my first step here, all I did was wrote it in standard form, highest degree to lowest degree, like a polynomial. So my first step here, I just rearranged it. I just put the 6th degree first, the 4th degree, and then the 2nd degree. That's all I did. So I rewrote it. That's all I did in the first step, rearranged it. Then I pulled out the greatest common factor, and this is the greatest common factor. So look at the cosines. There's 6 here, 4 here, 2 here. So they all have 2 in common, so I pulled 2 out. I have a sine x here, a sine x here, a sine x here, so they all have 1 sine x, and that's why I pulled out a sine x too. So that's how I got my greatest common factor here. So then I ended up with this. This is a perfect square trinomial idea. So it factors down to these. Notice I didn't keep factoring. Why? Because these are Pythagorean identities. This is the sine squared plus cosine squared equals 1 idea. This is a manipulation of it. If you didn't know that, like right here, you may end up putting this cosine squared x, and then you might put minus sine squared x plus cosine squared x. And what would happen if I did that? This cosine squared would get rid of this one, so I'd be left with a what? Yeah, and that's what's going on here. Okay? That's what's going on there. Is there some other one here you want to look at? Any of them?
Can you go back for a second?
Yeah. Oh, which one did you want? Blue 5? Okay. What was that in the red? That was the last one I did then? Okay. Stacy, if you need to, I'll come back to that in a second, okay?
Yeah, I'm good.
Okay. So, question about what I did, or do you want to see something that you did different? Yeah. What did I do here? Okay, so this is, and this was just what I did. Remember, I'll do it a different way in a second. I know it's been a long time ago, and when we did this concept, we were in Algebra 2 and we were all online, okay? Do you guys remember doing anything with numbers that looked like this? Complex numbers we dealt with in here, okay? And then we had some problems in here where I made you do this. Like, remember those? When we were division, remember doing this? Does anyone remember what we did with this? Because this is the concept that I used. What we did was we multiplied this by the complex conjugate of the denominator over itself. We multiplied by 5 minus 2i over 5 minus 2i. That was what we did. And the reason we did that was we were trying to get this. This is like a nasty thing to have a complex number denominator. By doing this, we get an integer in the denominator instead. Because the middle term, remember what happens when you multiply conjugates? The middle terms always drop out. So this would give me 25 minus 4i squared, but I squared was -1, so I get 25 plus 4, so I get 29 down here, okay? So this concept, I'm multiplying by a form of 1. So am I changing the value? No, I'm just changing its appearance. That's what I did here. I looked at this and said, I decided to change the left-hand side's appearance. And I chose to multiply by the conjugate of the denominator. So if it's 1 minus cosine b, I decided to do 1 plus cosine b over 1 plus cosine b. So that's what this happens. And then notice what happens when I multiply these. I get this, which is a manipulation of the Pythagorean identity. Boom. Okay, now that problem can be done just as easily and almost easier working on the right-hand side. So I'm going to go ahead and redo this problem, and I'm going to do it on the right-hand side instead. Clone this one. All right. And this time we're going to work on the right. Okay, don't. It's okay. I don't mind. You know, it's okay. No. So I want to rename the right-hand side. Okay. I can multiply the right-hand side by any form of 1 I want. Any form of 1 I want. I'm going to choose to multiply by sine beta over sine beta. Okay? So what do I get in the numerator? I get sine beta times 1 plus cosine beta over, the denominator is sine squared beta. Now, I want you to look at what I want over here, guys. I want this sine b to stay. I need to get rid of this, which means somehow I need to get that factor in the denominator, which means somehow I have to get this sine squared in terms of cosine squared. What do I know about sine squared beta? Well, look at our Pythagorean identity, guys. What would sine squared beta be equal to? 1 minus cosine squared beta. So that's what I'm going to do next. Sine beta times 1 plus cosine beta over 1 minus cosine squared beta. When you look at this, you need to see over there the difference of 2 squares. That's the difference of 2 squares, factoring it. It's like factoring x squared minus 4. How do you factor x squared minus 4? X plus 2 and x minus 2. So this turns into 1 plus cosine b and 1 minus cosine b. And then look what happens. Cancel, cancel. And what am I left with? Sine beta over 1 minus cosine beta. I can do it on the left or the right. Okay? Left or right, my choice. All right. Any other ones you want to look at on here? Yeah, Geiger. A question about what I did, or do you want to look at something different on it? What I chose to do? Okay. So, again, notice right here, I'm able to do what? There's a GCF. And the GCF here happens to be what I want, sine squared x. So I pulled out a greatest common factor of sine squared x here. That's all I did. That's the GCF. Then I get this. That is a manipulation or a version or like an alteration of cosine squared plus sine squared equals 1. So that's what I replaced it with. And then this cosine was just hanging around still. And then it's just multiply like bases, add the exponents. That's where this 3 comes from. Did you try it a different way?
Yeah, I like try to distribute cosine.
Usually you don't do much distributing. Usually you're going the other way and factoring in this. Okay. And usually we want to get down to what? Squares. So if I start kicking cosine through and doing that, then I don't really want things like that multiplied together as much. If you do that, I mean, if I approach it that way, let's go ahead and clone this page. Okay. I kick that cosine x through to start. Let's just do it that way. Let's see what happens. I would get sine squared x cosine x minus sine to the 4th x cosine x. Okay, so I get to that point. Now, if I want, I mean, you could probably go this route and this would work. This is what? 1 minus cosine squared x times cosine x. Okay, I can do that. Minus, watch over here, sine squared x, cosine x. All I did was took that sine 4th x and made it squared. I'm not going to do anything to this first piece here. I'm going to make this like I did this one. And you might be thinking, why am I doing all of that? What do I know I want in my final one? I would like to have a sine squared x in there. If I want, I could make this a what? 1 minus cosine squared x as well. So I can try to put all of this in terms of cosine squared x's, start doing a bunch of nasty multiplication, and I will guarantee we'll get to this if we keep going that route. Because right here I get cosine x minus cosine cubed x. My guess is if I came over here and made this a 1 minus cosine squared x as well, times the 1 minus cosine squared x, times the cosine x. If I went ahead and did this, I'd be able to combine like terms and stuff would start canceling out. Let's see what we get. Let's just keep going with it. Why not? Minus. Okay, what is this going to give me now? This piece. Who can do this for me? 1 times 1 is 1. Minus cosine squared x minus cosine squared x is a what? Minus 2 cosine squared x. And then at the end, it's going to be a what? Plus cosine to the 4th of x. That's this times a what? Cosine x still. So now I've got cosine x minus cosine cubed x. Now, I have to be careful here. So this cosine, I can think of multiplying through by a what? Negative cosine if I want. I could do that in one step. Or I could just go ahead and say minus, let's kick the cosine through. Cosine x minus 2 cosine cubed x plus cosine to the 5th of x. All right, let's do this. Cosine x minus cosine x. What are we going to do? Cancel out. Boom, gone. I've got a minus cosine cubed x and a plus 2 cosine cubed x. So if you're not following what I'm saying verbally, I'm going to get this. So now we start combining. This and this canceled. This and this gives me a cosine cubed x. minus a cosine to the what? 5th of x. Okay. Now what can I factor out of there? Cosine what? Cosine cubed. Cosine cubed x times 1 minus cosine squared x. Oh my gosh, what's 1 minus cosine squared x equal? Sine squared x. I mean, it's a lot nastier going that route, but it doesn't mean you can't. It does not mean you can't go that route. I mean, you literally could do that if you chose to. I mean, I think that's one of the funniest things about this. There's so many ways of doing it, but it really comes down to less about knowing what? Identities, and more about being able to do algebra skills. This is really checking your algebra skills. Being able to change appearance by using factoring, multiplying, right? Renaming fractions, all of that stuff is coming this way. That's great. I'm glad we did it that way. That was fun. I needed a little fun. All right. I think we should do some new ones here. Now, I will tell you, not all of the ones tomorrow. I mean, I can tell you on the quiz tomorrow, there are some that are easy to some that are a little more difficult. It's not like I've got 8 of them that are crazy, okay? There are some on there that are like 3 steps, potentially. All right, so I just want you to know that. So we're gonna go ahead and do some review here. I'm gonna give you this sheet. Let's see if I have that sheet handy here. We'll just go ahead and pass it out. Start. You onliners will find this posted. You're going to do all of these for homework. No, that'd be me and sadistic. But I say I grade 5 of them at random. I'm just going to choose 5 at random and grade them. Do them all. Do all 40 of them. Yes.
I have my history test tomorrow, so I'm not gonna be in here.
Okay. Then when I'm back next week, I'll just make it up. Okay. So let's go ahead and take a look at this. So I'm going to pull this over here. Here it is. This is what you guys are kind of looking at right now. Okay. So this first part here, we're not going to do anything with this. This is just checking algebra skills. Okay. So we're not doing that unless you can do that on your own if you want. Okay. So then this is an identity or not. We're not going to do this either. The answers are there already. We're not going to worry about this. So here we go. Prove the identity. That's the same as verifying. All right. So let's all do number 13. Right? Let's just start with the lucky number. I would like everybody to do number 13 right now. Okay. If you want, you can do it on the back of this. You can do it on a blank piece of paper, whatever you want to do. We're going to do number 13 though to start. Yep. Is it the modeling one? Science modeling? Since I'm not here tomorrow, I'd rather don't do it tomorrow. I want you to focus on this one to be good for tomorrow. Are you ready for this one tomorrow?
I'm not super bothered after
Okay, so I'd like you to do that instead. We need to go regroup on that, but that way I'd rather be here for the model. If there's some things that I need to explain, maybe when you take it. Okay, so let's just have you focus on this one right now.
I kind of didn't write all of it. I do the right side. No, of course not.
How many of you on the left-hand side expanded that? Anybody? You expanded the left? So did anybody do it on the right-hand side instead? You did? Kind of?
I'm gonna look.
But I'm saying you started on the right-hand side, is all I'm asking. Either way, it'll work on this one, guys. So if you started on the left, I'm just gonna, this gives you 1 minus 2 tangent x plus tangent squared x, if you did that. Okay? Now, is there anything you like already about the left-hand side? It has that minus 2 tangent x in it, doesn't it? Okay? Now, what everyone did is watch on the left-hand side. Just think about this. I'm just going to rewrite the order on the left-hand side. Rewrite it. 1 plus tangent squared x minus 2 tangent x. What is that? That's a Pythagorean, and that is secant squared x. Yeah, that's a pretty basic one in a lot of ways. That may not be the easiest that you might see in the quiz tomorrow. There could be one easier than that in the quiz tomorrow. Yes, where you don't have to multiply anything out like that. Like, there could be one where all you use is reciprocal and quotient identities on there tomorrow, like a gimme. Okay? Like, I think you had some of that on like last night's homework. There were a couple, or Mondays. So I'm not going to have them all be crazy. Trust me. I don't want you guys to fail. So it has to go from easier to there's some that's more complicated. Okay. All right. So I'm just kind of curious. When you did this, when you were doing this, Andrew, what did you do on the right hand side?
I mean, I didn't finish the right side, but I turned the squared x into 1 plus and squared.
So you went and did this. I'm just going to go ahead and say it. So you went 1 plus tangent squared x minus 2 tangent x. If I'm looking at that, I see a quadratic there. You guys see quadratic? If it's quadratic, guess what I'm going to try to do? I need to do what to it? Factor it. If I want to factor it, I should probably write it in standard form, which means I think, okay, that is tangent squared x minus 2 tangent x plus 1. And then I'd say, okay, how would I do this? Oh, okay, well, in order to get a tangent squared x, it would have to be tangent x and tangent x. In order to get a 1, it has to be a 1 and a 1. Because it's positive, the signs are the same. Since the middle term's negative, it has to be minus minus. Oh my goodness, they're exactly the same. Which means that's tangent x minus 1 the quantity squared. Is that the same as this? Yes, it is. It would end up being the exact same. Okay? It's the same, trust me. Because I can just go ahead and write this as this, put this at the end and make it 1 minus tangent x instead. Would be my choice. Okay, let's do another one. Let's do number. He's going, he's looking, he's looking. Oh, I think we should do number 16 next. Number 16. Which side you working on? I'm just curious. Which side are you working on? You work on the left? Who said that? You went on the right hand side? Did you approach it like that one I did earlier? That's what I wondered, okay. So you must have used like a quotient and a reciprocal identity on the left. Okay, cool. It is? No? Oh, let me get back.
It's like the one we did because it has the cosine squared and something else.
I'm gonna roll this when we get back.
I can't write.
What are you supposed to do?
So I have sine x plus 1
Oh, wait.
over cosine x. Yeah, because tangent goes to sine x over cosine x plus 1 over cosine.
Trash. Use it too.
Yeah, cosine over.
I didn't even write anything. I just said it in the right side.
Yeah, Mr. Schneider, I did exactly what you said.
But if you add,
It'll work. It'll work.
that's what they're trying to find out.
Jesus! Why?
That's when you're able to.
Didn't do it.
You're making me question, but.
Doesn't matter if it's like sine
What
squared
can I
x
do?
minus 1 is the. Yeah.
Well, they're gonna do the, and just to see. Oh, yeah, you can make it Christmas square.
Okay, so you. No, I didn't. I just made. Yeah. Okay, so then when you at now?
Oh, I guess, no, 'cause it's not, I guess.
What did we see? Remember the?
Oh, yeah.
It's like the opposite of the other. So what do you do? Sign? This one's just like the one where it was the exact, it was the opposite. It's number 5. It's the exact same as number 5.
They're the same.
Yeah.
Then you just add the
Change
change of both one.
No.
The sign and it. And then that.
Here, so this is what we get out.
Why is it?
So we multiply it.
What the heck? I don't know.
So if we work on this side, we multiply the sign b to the top of the model.
No, I didn't even write. I can't write. Sign X plus one with those. Sam's at sign X plus one.
Why would you do that?
I didn't do it. I didn't do it. I just lied to this.
Oh, really?
Yeah, I did exactly. Well, I can't write, so I just.
I did it in my head.
I did the first step. I did the first step. So when he said,
Did you do
well, I
the
mean,
right?
did you do the right or left? I did the right. That's what I did. I did the multiplication. I started it.
I don't even know how to do it right.
You do the inverse.
Or you can just do the left.
Okay, that's the thing. I'm trying to get the coach. Oh, that's. Yeah, oh, you did the same thing I was doing. Hold on. You multiply by.
Which is that? No.
Multiply by.
Yeah.
You do the opposite. You have to do what I did. Right? Sign.
I didn't know it. Can you do that? Isn't this a, that like perfect square? Right?
Multiply that to that.
No, the bottom. Isn't that a perfect square one? You can split it up into 2. So 1 plus sine x and 1 minus sine x, right?
Ryan, I might have done
Well, already.
that is way too.
Wait, did you get you get on the bottom? The bottom one. Yes, it does. 1 plus sine x and 1 minus sine x.
You know
And then look,
Sine square.
those cancel each other out. So then it's cosine x over that.
Sin X.
Sin X plus 1.
I only know they do that one because we busted it.
Sin X. Yeah. So just FOIL it. I don't know how to do the thing.
I did the opposite.
That's what I'm doing.
Wait, are you in the left?
Right. I mean the left still.
The left? You said you were doing right.
Well, Sam's doing more. I can't write.
Okay, where's he at? Oh yeah, you really got it now. Wait, what?
It was high. There's no point in studying.
No, I know.
It's gonna be a fail either way.
Do what I'm doing. You guess all. I'm gonna fail it anyway, but that's probably the best option for me because I don't know.
I don't know what that is.
Why didn't you multiply this one by
I just never heard of that.
I'm still not gonna remember it, so I might as well just guess.
You would have done like one more step.
That's for you. But that's
No, really?
Yes.
No, you're right.
Why?
I would.
Shut up. Because then it would be cosine squared x, which would get 1 minus sine squared x. So we could get that.
I don't know.
It would, this goes into that, and then you can cancel out.
You're wrong. I don't want to do that. I already started this way. It's gonna work.
You did my way, not mine.
No, that's not.
Dude, watch me.
Except for like.
Great, you can solve it in like 3 together.
Sign.
Right, he's solving it in like 2 steps.
Mr. Snyder, so.
He's like, yeah, you just need to do this and this. And
He does it in both ways, 2 steps in our mind.
I find that.
He's gonna get, he's gonna say, yeah, okay, so 5 of them are gonna be 3 steps. I'm doing everyone in that. 10, and I'm still not yet.
Like 2 minutes.
Because
In the last.
But I don't know how to do it.
No,
You get the out line. No, we didn't. Yeah, we did. I'll remember it. We did. Oh, I thought I had.
I have that, but I
Do you guys
don't
want
know
that?
where
This
we
one's
are.
this one's cosine.
Okay.
So after
So
we have
instead
to
of
just add
multiplying
together,
this
so
one
it'd be
on
sine
this
x plus
they did
1
it
over
with 1
1
minus. Make the bottom one 1 minus.
So 1 minus.
And then I did some fancy grades.
They did the 1 minus sine.
So this is technically 1, but it's also x over cosine
And
x.
I mean, it's so hard.
And so you get that.
Oh, they
Steps.
No, make the left, but you know how we did.
Then
You
you
only
have.
made that one square, so everything is
What you
right.
already it's because my
How's it
dad's
going?
over- Yeah.
I messed up.
I don't know.
No, you have
Okay.
to.
Yes, so that I
I
just started.
Oh, because agreed identities turns into 1
Yeah.
minus sine squared x.
I need that.
That's at the top.
Let's just correct.
Can we dance again?
And that turns into 1 minus sine squared
Yeah,
x.
he's every.
No.
And then on top you just square it.
I hope it's 20 points.
And then
I'm gonna
sine
leave it up.
that. You did it.
I hope I
So
did this
1 over
later as
1
150.
Yeah. So what does that do for Pythagorean identity?
Oh, it
And then
hurts.
this goes up, and your 1 still would be there because it was sine x times
Well,
1.
It's gonna be 1 minus 1 minus.
So what? Your sine x.
That's sine
squared
minus-
x, so then you just
Oh,
do
you have
sine
one.
x with sine x.
High braces.
Why is
And then they give you a routine.
It's so.
Just to wear it.
No. It shouldn't work, I don't like that.
So then you
Oh,
split that
yeah.
into 2, because it's a perfect square.
No, I was doing that.
Which-
I was doing it on the top.
Oh, I looked at that and I started to do it.
So that would be 1 plus sine.
You
And
better
1
put
minus.
this back on, because you don't want braces.
Wait, why wouldn't the one?
Correct in the parentheses. Because it's like multiplying the whole thing.
Why do you have 50?
I think I'm.
So it's like that thing he said, if it's x squared minus 4, then it goes.
I will mow on Saturday.
Minus 2 and x plus. So then there you just
Because
cancel
I'm
out.
gonna fail. Lucky me, I have to be here at 7 o'clock.
Dude, I'm not gonna be able to put you back on.
No.
All right, let's do this problem. Let's do this problem. Woo! Okay. I'm gonna go on the left-hand side. I'm gonna make this one right here, sine x over cosine x plus this is 1 over cosine x. This gives me, I'm gonna write it as 1 plus sine x on the top over cosine x. Okay, now I want to make this a cosine square. So this is kind of like that earlier problem. I'm going to multiply this by now cosine x over cosine x. So the numerator is going to be cosine x times 1 plus sine x over cosine squared x. That gets replaced with 1 minus sine squared x. One minus sine squared x. That is cosine x times 1 plus sine x over 1 minus sine x times 1 plus sine x. Cosine x over 1 minus sine x. That's just working on the left-hand side. On the right-hand side, you could just start off if you wanted and have multiplied by 1 plus sine x over 1 plus sine x. Okay, and you'll get to this, you'll do the same thing. Yeah.
So I did what you did on the left side, but I skipped like all the squaring stuff, but I went from Sine x plus 1 over cosine x to cosine x minus over 1 minus sine x. So
Wait, I'm sorry. Say so you did that.
yeah,
You did this.
I didn't multiply it by cosine x plus cosine.
What'd you multiply by? Anything?
I just like skipped it because I knew that it would turn into cosine x then over 1 minus sine x.
Okay, so it's just like when you did 2-column proofs in geometry. You got to show everything. Skip. I mean, you can say I know that vertical angles are equal, but you got to write it down anyways. All right. So that means that a person that doesn't understand how to do it can follow through and say, okay, now I know everything you just did and why it works. That's the reason. Okay. Boom. Next one. Here we go. Let's do number. Oh, I think we should jump to the right-hand side here. How about number? Ooh, I like that one. I like number 22. 22 is cute. It's cute. I like that. This is not a hard one. This would go into the category of actually kind of more of a easy one. Okay? This would go into the category of more of an easy one.
Oh, that's like
What is going on? Why is it easy?
It's because do the left side, the left side's easy.
I love doing the left side. Sine squared equals on my feet. That equals, yeah, that's it.
The
Wait, so then that one's also?
Yeah.
Oh, wait.
You did the
I know you have
teams.
I did 21.
You did 21. Oh, easy.
Riley was talking about the.
Oh, okay, it is.
Turns into one.
This one's also, I didn't.
Okay. Well, what am I going to replace that with?
1 minus cosine squared.
1 minus cosine squared alpha minus.
Cosine squared.
Oh, that's just 1 minus 2 cosine squared alpha.
Yeah.
Boom. That's why I said that's a cute one. Alrighty, here we go. Next one we're gonna do is, let's get out of these. Oh, I don't want that one. That's too easy. 21? Good.
21 is so easy.
21's easy.
Yeah,
We should do 28. 28.
I like 28. That's beautiful. For sure. Let's do 28. Let's do 28.
What the?
You would want 28. You want to spend the summer with.
I don't like the double variable. Oh, wait, no, it's not double variable.
Why? Why did you do that?
I'm so.
What did you do on both sides? Then we could divide by 5. Wait, we did one. I know that's a pet. Yeah, we did. Yeah, we did.
What's one?
I don't know how to do it.
This one looks like.
No, yeah, we did
This one
one
looks like
way
the
back.
secant plus.
Oh, remember?
It's actually here.
Minus. What?
1 minus. 1 plus 10. It's secant. Oh, but it's not.
One minus.
No, remember?
Plus one is earlier.
Right?
Not cosine.
What's that? You could if you wanted to on this.
No, there's a different way to do it.
I didn't say that.
Is this like a two?
No, I'm not. There's always, remember, there's multiple ways of doing this. Almost every one of these, we could do it a different way if we chose to. Let's see, after this, what should I torment you with?
Yeah, who decided?
I'm an idiot, bro. Come on.
That one's too easy.
It looks not easy.
I said no, but.
Is that what you do?
Well, you know, it has to be square.
Oh,
yeah. So it can't be that
You
easy.
can do that.
Well, I guess you just, okay, well, I just finish it out.
Well, no, then that just makes it see.
Can we cancel out?
Oh, now that's beautiful.
Yeah. So then it's one minus.
Just cross it out.
Actually-
Make this
Actually,
horrible.
Oh, yeah,
I guess you could do.
And then you can do the same on the other
Negative one,
side.
negative one equals negative one.
Some-
No, actually,
Yes, because there's parentheses around.
and then cotangent odd, cotangent is one. There's literally no right one.
You just know that there is. You literally just know that.
What are you talking
Because you have to do the top before you start. And you have to do the bottom.
No, that's like saying, look, that's like saying x minus one over.
Isn't there like imaginary parentheses over like the top?
Well, your numerator and denominator are always a quantity. So they are, they're just not written.
I'm
See,
saying,
it's
Now,
not
but now hold it.
I'm saying.
You can do, you can look at this multiple ways. You can think of this as a quantity over quantity. You could also think of this as this over this minus this over this. You can split it into two separate fractions if you want as well. That's always an option when you're dealing with fractions. Okay?
So the rule is you can't do like two sides of the
Right. You can't say I'm gonna do the same thing both sides and start working with them. You don't do that.
So you do one side first and.
And then if you want to stop and start working the other side, try to make it look the same, you can do that. That's okay. But there's no like moving things left to right. And there's no like, I'm gonna multiply both sides by 12. You don't do anything like, or I'm gonna add 5 both sides. You don't do that. You're not solving it. You're just you're manipulating it to change appearance. That's all you're allowed to do.
What do I need to do? Right, I would not see that. I would not see that first. I think it was negative.
There is no way, because it's
Look,
it's
if you cancel the
cotangent
teams-
minus one, but then one
No, if you
minus.
cancel the ones, you negative one and one, and then it's just cotangent over one.
That's
That's equal to one. Then you cancel the tangent. The sides.
No, because you can't see the right side negative one, because it's one minus.
I don't know where he's getting it. I don't want to.
That is not.
Oh,
I have
hold
no
on.
idea what to do.
Yeah,
Do you want me to put my first step, like when I'm thinking about doing this? Okay, I'll do that. Here we go.
I don't know anymore.
This, I'm gonna go ahead and write down fraction bar. Okay. So the numerator, I'm thinking this.
The isopressure. Should I not?
Okay, now that's all I'm thinking. I haven't done this one yet. I'm just seeing that as, why not make it one fraction in the numerator? So I immediately, I used the quotient here, and then whatever this denominator was, is what I made 1. That's how I got my version of 1. On the bottom then, it's gonna be what? Cosine of b over sine b plus sine b over sine b. Now, I'm not saying this is necessarily the best route to go. It's just what I chose to do. I could have just as easily multiplied the top and bottom by cotangent b minus 1 if I wanted, and done the whole like, oh, I'm gonna try to get perfect square in there and rename it, and I could do that too. I just chose to go this route. So all I did was quotient here, and then just changing a form of 1. So what do I get in the numerator? So I get cosine b minus sine v over sine v over cosine v plus over sine v. Now what happens here with this, guys? I want to think about this. That would be the same as this. Okay? What happens when you have the same denominators like this and you end up flipping this one? What happens? They cancel. Okay? So what you're going to get here is cosine v minus sine v over cosine v plus sine v. Is that going to help us? I don't know. Or maybe what I say to myself now is, hey, on the left, I have this. Could I do the same technique on the right and make it look like this? At this point, I could say, okay, right here now, I'm going to stop. And now I'm going to start working over here. I'll go the same way and see if it'll look like this when I'm done. Except this would be what? I'd make this sine over cosine, and this would be cosine over cosine. So now, instead of me continuing with this one, why not turn this one into sines and cosines now and try to get the same? You're allowed to do that. That's okay. It's just that I work with one side at a time. And when I get to this point here, I'm like, you know what? I don't want to go any further. This is harder to turn into tangents than this is to turn into sines and cosines. So now I would suggest you go over here and I'm going to rewrite this side. So I'm going to make this, we already said it, what? Cosine over cosine plus minus sine v over cosine v over cosine v over cosine v plus sine v over cosine v. You guys see it already happening? I mean, we're basically there. The numerator is cosine v minus sine v over cosine v over cosine v plus sine v over cosine v, which is cosine v minus sine v over cosine v plus sine v. And now I have done it. I have shown that they are the same. So that's an example where working on both sides one at a time allows you to show that they can be made the same. And that's easier probably to do it that route on this problem. Right? Doesn't mean it couldn't be done the other way. It just might be really nasty. Who knows? All right, that was 28. 28, I'm going to put BFF. You're my best friend forever. I like you. All right, 32. 32.
Left.
Oh, yeah.
Isn't paging started? What's that?
One.
I knew it.
Yeah.
Yeah, I got it.
Yeah. I already got it. Yeah. You're not, wait, you're not. Wait, you're not, wait, no. This was plus one. Let me take it out. It's not plus one. Yeah. Okay. And now. T squared. What's one plus Pythagorean? Is that in C or close? It's secant. Not equal to. And then squared. Squared. Times. Squared. Okay. So we already have one. Squared.
I'm right here. So I'm trying to multiply together.
It's not close.
That's a T. I don't like this.
No, do it like action. Oh, you made it silent.
I did one number goes on here. Because that's what you do. So this can actually get. Oh, so that would be one.
You can back up the secant.
Minus.
Back up the secant. The same thing we did over here. Pull out the secant.
Oh my gosh, I got it. Yeah.
That's another one. We do.
What are you?
Oh no, I'm so close. I got secant 3t minus secant. I'm like one exponent.
You said next one. This one time go about one.
Okay.
Oh yeah, just one time, one plus secant.
Can I do that?
Yeah. Why not? Why not? You can't do that.
Yeah. Because what if you were distributing, taking it away? Instead of adding.
Yeah, why?
Look at these.
You just pulled it out of thin air though.
That is not thin air. That is thick.
Okay.
This has.
Wait, can I change that?
You can square.
No, but the two can square
Square minus.
You can change two square.
And then
One
now you
minus
can
two
square.
One minus secant squared. So you do one.
Hold on.
minus secant.
Hold that up. You're wrong.
Or you just, you're making.
Times one minus secant.
So that would actually be better. That's. Sure. I got so oh yeah, so then it'd be secant.
Only one minus.
We got it. We fixed it. We did it. No, they're the same thing.
Yeah, we did all that.
No, we did it. We actually got halves. We did both sides.
Like, what do you mean? You did both sides?
Yeah.
Oh, so you just take secant squared.
You take secant squared out of this one,
and you take squared minus one.
It is a lot.
And then now we did both squared. What do you mean? Okay, so we use this.
We did it. We actually did it.
I did that. So what's that? So then it's not scary.
Hey, Ryan.
Oh, dude, I got it.
Do you guys work on both sides or one side?
I tried to do it one side, but I got like one, I was one exponent. I don't. If it's like x squared plus x, if you multiply both of them by x, you get then x to the fourth plus x squared.
We stop here.
No, that's not a form of
Because like this is what I have here. I have secant cubed t minus secant t, and it's 1 exponent on both of them. Oh, so it should be square.
Denominator should have been squared all along, which.
So then this would be a 4, which means it would be right.
Wait, 4?
Oh. So I was
Yeah.
right, except for the.
Okay, so,
That's a good start.
yeah, I can't decide whether
Those are all sines and cosines. I'll make them sines and cosines.
sine.
Yeah, so then I
You
think
write
we're-
C like a plus sign. Yeah. Instead of writing this for T, you write.
Right. So here we go. We're gonna go ahead and do this. I'm gonna just work on the left-hand side. The way Geiger did it is the way I was looking at it at my desk. Okay. So I decided to start off by pulling out a greatest common factor on the left-hand side. Okay. Which of course is tangent squared t. So I'm left with in here tangent squared t plus 1. Okay, that's what I get when I factor this out. This is secant squared of t. So now I have tangent squared t times secant squared of t. Now I'm going to put everything in terms of sine and cosine. So quotient here, this is sine squared t over cosine squared t times 1 over the cosine squared of t. Numerator is sine squared t over cosine to the 4th of t. All right? Okay, now, at this point in time, let's keep going with this. If I want, I can break this. I can think of this in multiple ways. I could right now replace this with 1 minus cosine squared t if I want. All right, so I'm going to make that 1 minus cosine squared t over cosine to the 4th of t. Right. Now, I'm going to split this into 2 separate fractions. So here's where this comes into play. When you see this, like 5 minus 3 over 7, that is 5/7 minus 3/7. That's what that means. This is 1 over cosine to the 4th of t minus cosine squared t over cosine to the 4th of t. Reciprocal identity. What does this become? There's my secant to the 4th of t minus, this gives me 1 over cosine squared t, which gives me my secant to the 4th t minus my secant to the square root of t. Okay. Yeah.
So going all the way back to tangent squared t down, yeah, no. So I just couldn't you just like replace tangent squared t with t squared after t minus 1.
You could, and then distribute it, and you're done. I mean, that's what I'm saying. There are multiple ways of doing a ton of these. So right here, this could be secant squared t minus 1. It's an alteration of the Pythagorean identity. distribute through, and you're there. Okay. All right, nice, 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 nice. Let's see here. I circled another one on here. Let's see, that was 30. That was 32. Ooh, I circled 37. I chose that because you guys don't like having a variable a t, so I made an X. I chose one with an X in it. So you can. I'm just being nice. This one looks nice. Let me do a smiley face next to it. Okay, let's see if I've done that email yet. Okay. Let's see, first period. Good, here, nope. Yep.
It's so hard to do.
That one's here, this one's here. Well, this one missing is true.
Well, how do you say it? It's definitely- I'm just thinking. There has to be fraction. Oh, science, look right there. Science for X, minus B. What is that? That's close. That's next square. And it's 2 rows next square. No. I don't know. There's a lot of ways to take away that. It's 2. Okay. I think it's 2.
I know.
So just need one that I did it. No, one sign for that. That 2 sign for X. What sign? You can't destroy that. You can't go with 2.
Maybe not that means.
That's why it's. Yeah, so it'd be 2. Whatever you want. Oh. Yeah, yeah.
Plus 1 minus.
Oh, no, I don't. Wait, so would it be fine? Because you can't, that goes right on the bottom. You had.
Okay, well, I did you.
I can't see that, like, you be like. Because that bottom is square. It isn't. It's just one. Sign X, sign X. You can take away the, like. So the 2 times, the 2 times, you can take that out of the bottom. Yeah, the 2. Not like. Because if you get X squared over X, it wouldn't be N. It would be Y. If X squared over X, it would be X. No, that's if you have 2X over X. Those are 2 different. Yeah. Alright. Okay, just change the first, change the top on the right. 2 cosine squared X. No, you can't do that. You can do that. I know. But
You should be 2 by 2.
yes. But you can't just say, oh, I'm gonna do that.
That's one.
Well, no, this is literally the sine squared minus one, right around that. Yeah. You were just talking about imagining things. Exactly.
Around the entire thing.
No. I'm right.
It'd be around the entire.
I know, I know.
You would have to distribute it to us. But you can't. Because then it was like minus one.
No, what you doing on this one? Think. Any thoughts? You're working on the right hand side? What side are you?
Left.
Left. You trying to do on? Trying right. That one? Right.
I think what I did was.
Left.
I don't think I did. Because I did.
Left.
I see. I got it. This one is actually this is
No, because of that addition subtraction. You can do that.
right inside.
On both sides. Oh, you're on the right hand side.
I
You're on the right hand side.
We're gonna back up.
Back up the angle.
Take away all X.
What a goober.
Yeah. How about? Get rid of them.
Baseline, subtract that.
Yeah.
Sine over cosine,
For the one.
so that's the opposite. Yeah, it is. Hold on. I'm getting some. Sine over, we're working on the other side. Sine over cosine is. And then so what's sine times cosine? Nothing. No, it was
Sine
the
times.
The opposite. We don't even need cosine. Sine times. What's sine times cosine? There has to be something.
I don't think, there has to be- no. I don't think, I don't think, I don't.
I know, but I don't. There's a plus one down. I don't want to do that. Right. Okay.
So, is I'm having my
First, look at
a bunch of verbs.
because even weeks ago, is there an answer to the wonder how to do the. Like if it's, I wonder if the parrots back in. What is that?
Yeah.
Like, yeah, but not, I should say, like, if it's like, you wonder.
No, you can't put that out.
So, I didn't.
You guys are making this one way too hard. You can do this on the left hand side.
Because I did too. I don't understand.
I know, I just. I just.
Oh, I see.
So, two.
One. I
I'm
did,
just- I'm multiplying by a form of one.
I did it by time.
You can do that, but just what happens is it ends up being better.
P2 step for sure.
So guys, in the top, what am I gonna get? Sine squared x. Because I'm multiplying conjugates, the middle terms will be gone. I'm gonna get sine squared x minus cosine squared x over the denominator. Now I have to multiply this out. So here we go. Sine squared x plus sine x cosine x plus sine x cosine x. Oh, baby, I like that. And then a plus cosine squared x in the bottom. And then what do I know that sine squared x plus the cosine squared x equals? So my denominator now has 1 plus 2 sine x cosine x on it. Numerator, I want it to be in terms of sine. Cosine squared x is 1 minus sine squared x. Sine squared x plus sine squared x minus 1 over
Could you do it from the right side?
Definitely make that.
I'm sure you could look at the, I'm sure you could work on the right hand side. Yes, Krista. You gotta vomit, don't you, after that problem? I know. Go ahead. Do what you gotta do.
Oh, no, it's a question mark.
Oh, what? Yeah, what up? Which one was that?
Modeling.
I'm gonna ask Mr.
You got
Sarah.
3 sessions. One more you had to draft sign.
Might be, might take it. Yeah, take it for me.
Oh, yeah.
Sure he would. I'm trying to read a pistol there. You might
You do that online.
Right, I'm gonna ask Mr. Snare if he wants to take my.
Evan said.
Yeah, I didn't say.
Oh, this.
That is the mid-twist R, but
Maybe
I put
just-
it in there. Oh, yeah, what's that? When I get to it, I keep a list, I always do almost, I do almost all extra credit at the end of the quarter.
Oh, yeah.
That's what I do.
Dancing.
The sine squared x minus cosine squared x?
Yeah, how does that get two sign?
Because cosine squared x can be replaced on the Pythagorean identity with 1 minus sine squared x.
Yeah, I got that, but it's. How does that?
First grade math.
Because you gotta distribute the negative through. So you get a sine squared x plus another sine squared x, that's 2 sine squared x's. And then the minus 1, it's half of the end.
Mr. Schneider?
Yep.
So I missed Friday, and I think you guys, I was meaning to talk to you about it. It's like the, you take an account thing, and you have to sign up on Right State or whatever.
Yeah,
I didn't do that.
okay, so that, the instructions are all online.
So just do it.
Yeah, the big thing you have to do is make sure you use a non-school email address when you're doing the right state part of the application.
Okay. So then it's Right State, not one of the other.
It's right state. Yeah, the links are there on the Google Classroom. Just follow them, okay? See you guys.